at cryptography. Well, before we look at cryptography, I want to mention that the network security itself does not happen in any particular layer of the network. That's why it's sitting in its own chapter, because we can implement security in any of the layers. For example, in the physical layer, we could take physical security measures, such as locking doors and using smart cards, physical objects to log into the network, or reading our retina or fingerprints or other physical things to gain access to the network, or even physically protecting cables and fiber optic cables if somebody wants to tap into them. So that has to do with physical layer. And partially data link layer, because partially data link is in hardware. In the network layer, what we do is install firewalls to keep bad packets out. And we also have something called IP security, Internet Protocol security, in the layer 3 or the network layer. In the transport layer, what we do, that's where we have connections, is we can encrypt entire connections from one process to another process, and everything is completely encrypted. In the application layer, we handle the authentication and non-repudiation. Authentication is where we are asked for username and password, and non-repudiation deals with the digital signatures and signing documents. So at any of the layers, we have some part of security being done. So how do we encrypt messages? So let's look at encryption model or cryptography. With encryption model, we have something called cipher. Cipher is a character for character or bit for bit transformation we also have code. Code is different by cipher from cipher because that replaces one word with another word. Or symbol. Other things that we have, plain text is the message that we're trying to send. This is, let's say this is an email or some kind of text that we want to send through the network. After that, we will take this message So the encryption method will take a key and apply the key to the plain text and convert it to a ciphertext. So we have encryption key So once we take the plain text and feed it into the encryption algorithm using the key, we will produce the ciphertext. So C is the ciphertext. So that is considered secure because it's not readable. So for anybody sitting on the network, they can look at that. We have two types of intruders. One is passive intruder, which means they just want to read the information. And active intruder is what? They don't just want to see it, but they want to actually do something with it. That's why you see these two arrows, one going up and another one coming in. Because this intruder took the message and changed it and sent it back, so now it's been modified. So he did it this. Violated the integrity control. In any case, the message is encrypted. It's unreadable. They can pick up the actual message with the encryption and everything and just resend it again later. That's called a replay attack. So let's say if that message was we were withdrawing $1,000 from our bank account. So the intruder picked that up. They can't read it because it's encrypted, but they can record and resend it again later. So one more time, $1,000 is withdrawn from our bank account. They withdrew it twice in this way. So they can do that. And then if we actually want to read the message, we need to apply a decryption algorithm that's going to convert the cipher back into a plain text or readable form. So G is decryption method. Now the decryption method has to again use a key. It has a key here, so I will say KD because this is, it can this key be the same key that was used for encryption and decryption? Or do you think that that's a different key here? So if we take the ciphertext and apply the decryption method with the decryption key, we should obtain back the plain text. So this is happening on the sender's machine. This is happening on the receiver's machine. And everything that goes through the network is ciphertext. So, is this key the same or it's different?
It would have to be the same.
It can be the same. If it is the same, it's called a symmetric key. If it's symmetric, this means the encryption key is equal to the decryption key. Now, if we want to make this more secure, we can have two different keys. This key will be a public key, and this one private. In that case, we will have asymmetric or public-private. That's called public key cryptography. The reason we have that is because of something called Krakow principle. Krakow principle means all algorithms must be public, only the keys are secret. So what happened is that in the past, when the first encryption methods were created, they tried to keep the method secret. How do we convert this into ciphertext? This part was secret, but unfortunately it never works. No matter how hard they tried, always somebody figured out what was the encryption method. So eventually they decided to allow the method to be public knowledge, and the only thing that's private is the actual key. And after some time, even they make half of the key public, and only the other half is private. So we have a pair of two keys, one is public, and just the decryption key is private or secret. So everything is known. The encryption method, the decryption method, the encryption key. The only thing that's not known is the decryption key.